Howdy, and welcome to the first video in Module 15, which is the second of two modules introducing the proof rules for the Boolean connectives. In the last module, we looked at the introduction and elimination rules for conjunction and disjunction. In this module, we'll cover the proof rules for negation, the last of our three Boolean connectives. As you might expect, negation follows exactly the same pattern as the identity symbol and the other two Boolean connectives. It has an introduction rule and an elimination rule. But there is a twist to the introduction rule for negation. In order to state it, we need to use a symbol that we have not yet encountered. This is the contradiction symbol. In this video, I'm going to focus just on the contradiction symbol, so that we have everything we need in place before getting started on negation in the next video. As with every other symbol in our logical system, the contradiction symbol has an introduction rule and an elimination rule. So I will explain both of those, and then in the next video we'll go on to look at the introduction and elimination rules for negation. Working on the contradiction symbol has two additional advantages. First, it gives us more practice in working with subproofs. And second, the rule of contradiction elimination brings into focus a feature of logical consequence that many people find puzzling when they first encounter it. This is the fact that you can derive absolutely any sentence as a logical consequence of a contradiction. So I'll explain why this holds. The exercise for this video will show you how the contradiction rules work in Fitch. So here are the learning objectives for this first video in Module 15. After watching the video and doing the required exercises, you should first understand the role of the contradiction symbol in our formal system. Second, be able to apply the introduction and elimination rules for the contradiction symbol. Third, understand why any sentence can be derived from a contradiction. And fourth, be able to use the proof rules for the contradiction symbol in Fitch. So let's get going. To see why we need the contradiction symbol, think back to the informal proof technique of proof by contradiction that we encountered back in Module 13. Here's the basic idea. In order to use proof by contradiction to derive C, you need to show that not C leads to a contradiction. And this is because if not C leads to a contradiction, then not C cannot be true, which means that C must be true. In other words, you prove that C is the case by showing that it is incoherent or contradictory to suppose that not C holds. In other words, you reduce not C to absurdity. Hence the Latin name for proof by contradiction, reductio ad absurdum. So the contradiction symbol gives us a convenient way of registering in our proof that we've obtained an explicit contradiction. The contradiction symbol is written like this. Not all logical systems use a special symbol for this job, but they all have some way of marking the special role of contradictions in logical proofs. I personally think that our textbook uses the contradiction symbol in a very elegant way. You should note that it's a freestanding symbol. It does not combine with any other symbols, and it only ever appears on its own in a line of our proof. So the introduction rule for the contradiction symbol tells us when we can write the symbol down in our proof. And this is how the rule of contradiction introduction looks in our standard format. A few points. Basically, we can write down the contradiction symbol in a line of our proof if we have derived both P and its negation not P in earlier lines of the proof or subproof. P can be any sentence, of course. You don't have to apply conjunction introduction to derive the contradictory sentence P and not P. And then finally, deriving both P and not P in a subproof does not allow you to write the contradiction symbol in the main proof or in any subproof to the left. So this final point is actually very important. Sometimes when you're doing formal proofs, you'll have multiple subproofs going on, and it's important to keep track of which is which. As I've said before, Fitch notation is really useful with that. Here's a quick visual illustration of what you can and cannot do. So the first attempt to introduce the contradiction symbol is perfectly fine. P is derived in a subproof to the left, or it might be the main proof if we have just one subproof. So it's still in force, as it were, in the subproof to the right. In contrast, though, we cannot apply contradiction intro in the second example. The problem is that not P is derived in the course of a subproof to the right of the subproof where we want to apply the rule of contradiction intro. As a famous logician once said, what happens in the course of a subproof stays in the subproof. Some of our proof rules allow us to pull the conclusion of a subproof out of the subproof and back into the next proof to the left, but generally speaking, you can't use anything that is derived during the subproof. Okay, so that's the rule of contradiction introduction. It tells us when we can introduce the contradiction symbol. But once we've got a contradiction symbol, what can we derive from it? Well, it turns out that there are two ways of drawing conclusions from a contradiction. The first way is to use the rule of contradiction elimination. This is what we'll look at now. The second way is to use the rule of negation introduction. We'll look at that properly in the next video. But for now I want to show you the rules side by side so you can see how they differ. Here they are. Look at the rule of negation introduction on the left-hand side of the slide. You'll see that contradiction is derived in a subproof that begins with the assumption P. In other words, you have a subproof that starts with P and shows that P leads to a contradiction. Then in your main proof, or in the subproof immediately to the left, you can derive not P. When you're using the rule of negation introduction, you can only write down the negation of the sentence with which your subproof began, and you must write that down in the main proof or in the subproof immediately to the left. Now look at the rule of contradiction elimination on the right-hand side of the slide. Here everything takes place in the same proof or the same subproof, if this all takes place within a subproof. What the contradiction elimination rule says is that if you've derived a contradiction symbol at any point earlier in your current proof or subproof, then you can write down any sentence whatsoever. But you can only do this in your current proof or subproof. If you're working in a subproof, then you cannot pull the sentence out and write it down in the main proof or in the next subproof to the left. Here's an illustration. You cannot use contradiction elim, for example, in either of these two ways. Both of them illegitimately export the sentence P out of the subproof that contains the contradiction. You may find it helpful to remember the rule like this. If you're applying contradiction elim to derive a sentence P, then you can only write down P directly below the contradiction symbol. This still leaves us with one question though. What on earth justifies this rule? Why can we write down anything once we've derived an explicit contradiction? Am I really saying that this is a valid argument? It is raining and it is not raining, therefore the earth is flat. Yes, actually that's exactly what I'm saying. This may not be the most helpful argument you'll encounter all day, but it's certainly valid. And so is any argument that has a contradiction among its premises. Here's why. It basically follows from the definition of validity. An argument is valid if and only if it's not possible for the premises to be true and the conclusion to be false. But if the premises include a contradiction, then there's no way in which the premises can be true, because contradictions cannot be true. And so there's no way in which the premises can be true and the conclusion false. And this same line of reasoning can be generalized, of course. Any argument with inconsistent premises is valid. To say that a set of premises is inconsistent is to say that they cannot be true together. And if a set of premises cannot be true together, then there's no possibility of them being true and the conclusion being false. It's irrelevant what the conclusion is or what it says. Any argument with inconsistent premises is valid. So that's the justification for the rule of contradiction elim. This rule writes into our logical system the basic fact that any argument with inconsistent premises is valid. After all, nothing is more inconsistent than a contradiction. Finally, you probably figured this out by now, but let me be explicit about how you justify applications of the rules for the contradiction symbol. You write down the rule, obviously, and then you write down the line numbers for the earlier steps on which your application of the rule depends. To illustrate how this works, here are both rules applied in a single proof. The proof uses the rule of contradiction intro to introduce the contradiction symbol, because we have derived both P and not P. And then it uses that contradiction to derive Q using the rule of contradiction elim. So to justify the rule of contradiction intro, you write down the number of the line where P is written and the number of the line where not P is written. So in this case you write down M and N. To justify the rule of contradiction elim, you write down the number of the line with the contradiction symbol in it. You do not need to cite the lines with P and not P. So in this case you only write down S. With that, I wrap things up for this video. Here are the key points to remember. First, the contradiction symbol gives us a way of registering in our proofs that we've derived two sentences that contradict each other. Second, the rule of contradiction intro allows us to write the contradiction symbol down whenever we've derived a sentence and its negation at earlier steps in the proof. Third, the rule of contradiction elim allows us to write down any sentence whatsoever in the same proof or subproof as the contradiction symbol. And then fourth, the justification for the rule of contradiction elim is the basic fact that any argument with inconsistent premises is valid. You should now do the assigned exercise for this video. It will show you how the rules of contradiction elim and contradiction intro are implemented in the Fitch program. Once you've completed that exercise, it will be time for the next video in this module, which will introduce the proof rules for negation. See you then.